positive sign, which means you can only use on sequences this for your domain, these types of numbers. You're restricted. Now please tell me, it was at the start of the handout that you guys received last week? Just a definition, okay? Now, I may have placed some examples on your handout also, but I brought something in also here. In fact, this might be one on your handout. It comes down to, guys, something like this. I'm gonna make this infinite. They give you some terms, separated by a comma, and they're gonna call this a sequence. But they're gonna ask you then, can you come up with a formula, like f of x equal to, and name a function that would represent what these terms would represent. So I think last week I did the function notation, and you guys can remind me, I think we came up with 2x minus 1. Did we? May have used n last week for 2x minus 1. And if I go back to my domain, restricted domain, on a sequence, if I put a 1 in here, if I put a 1 in first, yes, I'll get 1. If I put a 2 in here, I'll get a 3. Put a 3 into 2x minus 1, I'll get a 5. So that is giving me the numbers in that sequence. And that's where they get the function idea. Chapter 11 though says, please have students rewrite this in this form. We're still talking about a function, but they like the notation a subscript n is equal to 2n minus 1. And Philip, the reason they ask that, or have you prefer this, they may ask you to find a specific term in that sequence for my example. In other words, I may want to find the, I think I used the 50th last week, find the 50th term in that sequence, which means you really go to your formula and replace that by 50 to your work, and I think it's 99. And I think that's where we sort of were last week. Is that true, guys? Can't go wrong. Now, number 2. Here's one. Are we ready for this? I think we are. Sine of 5 or 6. Now hold on, Professor, I thought that was back in the tree. I thought it was back in chapter 6, chapter 7, chapter 5. All of a sudden put a comma. Cosine 5 or 6. 3 halves. Let's make this, again, infinite for right now. You could have a strange sequence. Still defined as a sequence. Term separated by a comma. And they're going to ask you, can you look at this, and it's a little bit tougher here, and come up with a formula. It's called a subscript n, based on what you see. I would hope, and this is a combination of trig, that you recognize this is the same as 1/2. And the cosine of 5 or 6 is what? Radical 3 over 2. I can change that real quickly. Of course, 3 halves is my third term, and then these terms go on forever. Now, I need someone, be careful, who has an idea of how could you write a formula, a function, that would give you those terms. And when you think you have it, let me know, and I'll write the formula out, and I'll use a subscript n is equal to, I'll write this in terms of n, like your textbook does, and we'll do that. I gotta get a 1/2, when you give me the formula, I gotta get a 1/2 when I replace n by 1 in your formula. When I replace n by 2 in your formula, I gotta get that strange thing. N by 3, I gotta get that third term. So if someone thinks they have it, let me know. And we'll try. I'm just trying to point out sequences can come in different forms. Do you want to have an idea? This one's tougher. This one up here was fairly easy with the odd numbers. This one's a little mix. You want to think they have it? Barbara, go for it.
3 to the power of...
3 raised to the power of something?
Yeah.
Hang on. Okay, what?
And n minus one,
Wait, up here?
yeah, over two,
The n minus one over two?
yeah,
Wow, okay. Hang on. And that's it?
over two, the whole thing.
All over two. So a two and another two.
The whole thing over two.
Yeah, I'm gonna do that. And I'm saying, you have a two also left up here. You want both these?
Yeah.
Want both those? Wow. Now this is creativity. Now as a student, could I have been that creative? I haven't checked it yet to see if it's gonna make any sense. I doubt I could at that time. Been as creative as, he just gave me this. Who on earth would think it looked like this? Far about. Thought about this. Now on the side here, far about here goes, we'll check a few of the terms. The first term, a subscript 1, I'm gonna go to what he gave me and replace n by 1. Which I think, if I do this correctly, this becomes 3 raised to the 0 over 2. 1 subtract 1 is 0, so 3 raised to the 0 is the same as what? 1? Anything raised to the 0? So we end up with 1 over 2, first term. Second term. Check that also with his formula. 3 raised to 2 minus 1 over 2, all over 2. If I'm careful, that's 3 raised to, looks like a 1/2, all over 2. And I know 3 raised to the 1/2, and so do you. That's the square root 3 over 2. Second term. Oh, it was the second term. Now, we messed up on the third term. Let's see if we do. Third term is up here with the help of his formula. A subscript 3 is equal to 3 raised to 3 subtract 1 over 2 over 2. Guys, that's 3 raised to the, my goodness, right here is what? 2 over 2, that's a 1 over 2. He gets a 3/2. Looking back at my sequence, it was 3/2. Nice. Now, are there other versions that could have been given here and would have worked? Yes. Farbod, should I ask, what were you thinking to get that? Share with us.
I thought the one is 3 to the power of 0, the second one is 3 to the power of 1/2, and the third one, I was thinking about the denominator.
You're in the numerator.
Yeah,
Up here?
yeah.
Look at this. So in your thinking, you said, I thought this is 3 raised to the 0,
Yeah.
which is 1. And you said this is 3 raised to the 1/2. And this is 3 raised to the first. To sort of get into what this is all about, right? That's what you were thinking. And you said they're all over 2. That's why you asked me to put a 2 down here. You said, no, they're all over 2. And that's the type of thinking he did. I guarantee if I gave you enough time, which we don't have today, other students could come up with more than likely a different formula. And I could test it and probably come up with the same terms that he did. I love that though, thank you. Okay? Now, could I have sat there and done that fast? No, I doubt at all. As a student, I could not have seen that so quickly. By the way, just out of curiosity, did anyone try something else? Besides his formula? And guys, he finally asked me to write this. Where is it? Here's the answer. That will give me those terms. Now, with that said, I'm trying to prep you for the final exam as I do this, guys. Because the final exam is cumulative, it covers everything. Therefore, I want one more sequence that looks a little different, but here goes. ln 1/2, comma, ln 2/3, comma, ln 3/4, comma, and let's have this be an infinite sequence. not just numbers, it could be expressions, just as long as it's the sequence. Now I need a formula for this one. Oh, I'm here.
So ln,
Hang on, ln.
n over n plus 1.
Wow, 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 wow. Mr. Park, we have been blessed this summer. We have been blessed with students. Guys, I'm gonna test it. Amir, you are correct. I'm gonna test it. A subscript 1, if he's correct, should be ln of, replacing n by 1, 1 over, and guys, that becomes a 2, 1 plus 1, and that's what that was. The second term, if he's correct, would be ln of, replacing n by 2 would be 2 over 3. N over n plus 1, got it. And of course, the last one, I'm sure it's going to check. Here goes. ln of n over n plus 1 is, in this case, 3 over 4. And looking back, that's my third term. This is the name of the sequence I was looking for. So why did I bring this in today when I was planning for today? Your final exam is on Friday. That's one nice thing about me creating that last test, I get to combine stuff. That's what I like about the final exam. All of a sudden I'm talking about sequences, and all of a sudden you get to see LNs. And I'm talking about something else, all of a sudden you see trig coming in again. So I can play around with this and put it together. Guys, any concerns here? Just what a sequence is and how to come up with a particular term, or how to come up with a formula. Thought I'd bring that in, I did. Nice, cute. Now that said, did I jump right into it? I sure did. Here's a major part of this. Part 2. Summation. Now they'll ask you to take these terms and add them up. So they're going to give you something to work with, list the terms, and find a grand total, add them up. Now if they want us to add them up in mathematics, we use a symbol. Sigma from the Greek alphabet. So if I see that in mathematics, that means sum. They want us to sum up something. With that said, I'll use that symbol here shortly, sigma. Let me start out with something, you may have heard this story before in another class. If you're asked to take the terms of this sequence, and I'm going to add them up, and I'd like to go through 100. If on the final exam, which is not going to happen, but if on the final exam I ask you to add up the first 5, you say, wow, man, I'm going to do well in that final exam. I got an A for the course, I'm sure. So you just add up 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is what, 10? 10 plus 5 is what, 15? And you're finished. No, I'm asking to add up the first 100. And it's going to lead me into something. I'm sure somewhere, some teacher, some instructor probably shared with you a story behind this. About a famous mathematician. Mr. Gauss. Mr. Gauss, the story goes now, and they need a history of math course being offered here. We need more history. These mathematicians, what type of people were they? And I've taken a few history courses, and some of these mathematicians were crazy. Just crazy people, but bright, real bright, too bright. Okay, this one is Mr. Gauss, and the story goes that he was so bright, if I remember the story correctly, like a 7-year-old kid, that he was just out there. And they noticed that he was just out there, so they paired him with another great mathematician, He says, here, you take him, work with him, because he is way out there. He's doing stuff that we don't expect a 7-year-old to do. I could not have done this at 7 years old myself. Not the thinking he did. So the story goes is when he first met his mentor, the other math person, the question was, add these up. Now here he is asking a 7-year-old to add these up. So, well, let's see if we can do that. And the story goes something to the effect that he had his hand up, the kid did, 7-year-old, had his hand up, and the mentor thought he had a question. He had the answer. Within, soon as the mentor almost got it out of his mouth, add up the first 100, he had the answer. These are terms of a sequence being added. So I'll show you shortly how that looks with this symbol here shortly. But first, the story behind it. Does anyone have an idea? And maybe you've heard the story before. Mr. Gauss is 7 years old. Does anyone know a way to find the sum of the first 100 positive integers quickly? And get a grand total? Then I'll show you what he did. Miriam?
Take the first term and the last term.
Okay, you know that. So these two will add up to 101.
And then multiply it by half of the final, so 50 in this case.
Multiply by 50. So you say 101 times 50, which I think is 5,050. So you're saying Mr. Gauss at 7 years old said 5,050. Like that, right? Okay. I like that thinking. Now here's what I understand from the history class, what he did. And it's going to give us a formula to work with. He did this. He said, well, I was asked to add these up. Now who, especially a 7-year-old, I think that was his age, who on earth would think of doing this? But that was the question. Please add those up. Well, he says, I should get the same answer if I did this. Thank you, Arena. Should you get the same answer if he adds backwards? Should it be the same sum? So he called this like this is the sum. He said, hold on now. This is the same answer, same sum. Then he noticed something going on here. He said, wait, the way they're paired up. Who on earth did they do this? The way they're paired up. Here I'm getting to the 101 now. Will these pairs, 1 plus 100, 2 plus 99, 3 plus 98, 4 plus 97, even the one she gave me, will they all sum up to 101? Is that true? So what he did, he says, I have 100 101s. Written like this. Jonathan, would you think like that? I wouldn't either. No, I'm 7 years old. 100, he says I have 100. Does he have 100? But that's when he added twice. So this is for 2 S, 2 sums. Just straight and backwards. And then he divided by 2 right quickly to find the sum. Found the sum to be equal to, sure enough, Miriam, here goes. 50 times 101 is 5,050 for the grand sum. Arena, Mr. Parker, would you guys have thought about that if you back in elementary school, or even before you got to elementary school maybe, to find the sum of the first 100 positive integers, would you think to do that? I wouldn't. I would not have. And all of a sudden, this guy did it, and all of a sudden, it came. Gave us a formula, which I don't have on the board yet, that helps us. That's what he did. He said backwards. And then 5,050 is the sum of the first 100 positive integers. Mr. Gauss, thank you. Now first, I'd like to now bring in the summation. So he was asked to sum up sigma. Hey guys, what's the notation here? I think the textbook uses a he was asked to sum up from k is equal to 1 to 100, and inside here, k. Translate. They want you to start the base of this sigma notation, replace, and you will have a formula to work with. Replacing that formula on the side of the sigma, start with the base, replace it by 1, then you replace it by 2, then you replace it by 3, until you reach the top. And of course, sigma itself says you're adding as you do this, and you will get this. So this is equivalent to, in sigma notation, you're summing up 1 through 100 of k. Okay? Now, what I did, I think I did on the handout, guys, I think I did. Let's hope I did. Before I get to formulas, I had to do this. Mr. Gauss's story, I had another little short story, a little thing to show you. Part B. I'll go back into the formulas, and I think I have the formulas all written on a sheet for you. I thought this would be interesting. Before we jump in and start all the summation, I want us to start with 1 and do this. Which might mean translate add forever. And inside here, the formula you'll follow is, it's a little strange, but here it goes, it's this formula. I thought maybe we should see this now. Okay. Now, if you refer to the handout I gave you or the textbook, there is no formula for this. There is no formula for this. And some students get frightened. They say, Professor, you're a little tired today. It's a Monday. You sure you won't put infinity on the top there? Yeah, it says the sum forever. Now, we'll write a few of the terms out, guys. We're supposed to start with 1. Always start with the base. And I gave you the formula. So the first term will look like this. 3/10 times 1/10 raised to 1 subtract 1. That's my first term. Replacing k by 1. Then you jump up and replace k by 2. Same formula. 3/10 1/10 raised to the 2 minus 1. Let's try another. Third term. 3/10 times 1/10 raised to the 3 subtract 1. Now we'll do this. This one you're supposed to sum forever. I've written the first 3 terms. And we're supposed to get a grand sum, a grand total. No formula for this one. Or about, I see that smile on your face, you probably know the answer already. Hang on. I'm stuck. Let's say you're stuck. You say, wait, Professor, it wasn't quite as obvious as Gauss. This is not Gauss. Gauss did this for us. This is something else. This is something from Arena, probably math 8. Did you guys do some summations through infinity?
Yeah.
Math 8. I thought it's time to show you. Before I jump back into my formulas. Sum forever, you say, Professor, that's crazy. The answer is infinity. Oh no, the answer is, there is no answer. It just keeps getting larger and larger and larger. If you keep adding forever, common sense says it just keeps getting larger, Professor. And therefore there's no answer. There's no answer. There's an answer here. Crazy that you do this, which means keep going, add forever. There's an answer. Now give me some insight. What might you do if you were, let's say this were an extra credit problem with 20 points on the final exam? What would you do? Now I know what's scaring you is that Yeah, they are.
Then plus together, then the second, then the multiple, then minus together. Then minus each other.
There's like, you're telling me there's a lot going on there. I heard that 1/10, right? For sure. Now, if you think you have the answer, or about you give me the answer real quickly for this one. Don't tell me the answer, but you think you know the answer. Just don't say it. If you think you know. Okay, guys, you're gonna be shocked. You're gonna be shocked what the answer is. That's why I brought it in. I had to bring it in. I don't think your textbook did this. I had to bring it in. Yes.
We start by maybe factoring out the 3/10.
You can factor out the 3/10. I can factor out the 3/10. Absolutely. I see that 1/10 he was talking about. I can take out 3/10. Caroline? I'll give you a hint. Here's a hint. It's really, 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 and I keep referring to the middle school, it's really a middle school problem written with some sophistication. Middle school kids across the street, they would not recognize it like that. Wait till you see what the answer is. The answer that's going to come out, they would recognize. That's the hint. It's a middle school problem. Look like it's so sophisticated. You got sigma, then I doubt they know what a sigma means over there. But the answer coming out is a middle school answer. Guys, let's do this. So I won't spend too much time on this. Help me out now. Do not let me make a mistake here. Let's write out the value of the first term. Well, I see 1/10 raised to the 0, that's 1. Anything raised to the 0 is 1. Times 3/10, so the value of the first term really is just 3/10. Let me jump down to the second term. This says 1/10 raised to the first, which is 1/10. Times 3/10 is 3/100. The third term, on the end, 1/10 squared, 3 minus 1, that's 1/100. Times 3/10, guys, that's going to be 3/1000. And it goes forever. So I've written out the first 3 terms, just so we get some idea. Now, Philip, here's the connection to the middle school. And some students may see it right quickly. I know, if they ask me to add these up, I know from middle school, I could say, wait now, Professor, I know this in decimal, like that. I know this could be expressed as 3/100 as 0.03. This could be expressed as, with the decimal, 0.003. If I line those up on the side here and say, okay, they're asking me to add those up, I've got 0.3, 0.03, 0.003, and it's supposed to go on. Right now, even at this point, what do I get when I add them up? I see 0.333. I would assume that 3 repeats forever. You guys see that connection in the decimal? When you add them up, you get a string of 3s. Now, I think across the street, they do this, you probably have seen this. They write this as 0.3, where the 3 repeats. 0.3 is a little bar across it to show it repeats, which it does. Now, can anyone tell me from middle school, what is 0.3 where the 3 repeats represent? In other words, that's the answer to all this. You see 0.3 for the 3 repeats. Now this is way middle school. 1/3.
Is that considered rational or irrational?
That's a rational answer there. 1/3 the answer. Nima, that's the answer. We're back in middle school. There comes that 1/3. Give us the answer. Now, can I give you a formula that may do this? I think Math 8 arena. You guys in Math 8, do you have formulas when they say sum forever? Summation formulas?
Yeah.
Okay, this one I brought in just to show you they're out there. be shocked when you get math 8, when you actually sum forever. They will give some formulas back then when you reach those. Guys, make sense the way we line this up? 1/3. Who on earth would think that all this mess, Caroline, look at how nice that looks. Looks so sophisticated and written out and all this, doesn't it? Then all of a sudden the answer's what? I'm gonna try one more. I just thought about this, but someone's gonna have to give me an answer quickly on this one. Let's try C before I get to my formulas where I need to be. Summation. Start with k is equal to 1 through infinity. Think a good way to do this. I hope so. Nine over 10, 1/10, I'm using 1/10 again, raised to the k minus 1. Oh boy, am I going to try this? Yeah, I'll try it. Who thinks they know what the answer for this one might be? If you want to know. Okay, let's write out some of the terms, like I did for the last one. Jonathan, if I write the terms out, I know the first term is 9/10 times 1/10 raised to the 1 subtract 1. I'll come back to that. Second term, written out, is 9/10 1/10 raised to the 2 minus 1. Let me write out the first three terms. 9/10 1/10 raised to the 3 minus 1, and they're asking us to add forever. I think those are the first three terms. Guys, here goes. I think 1/10 raised to the 0 is 1. First term will be merely 9/10. This one got 1 over 100 times 9/10. What is that, guys? 9 over, did I leave something out here? Oh no, 1/10 times 9/10. That's 9 over 100. Third term, I think it's a 9 over 1,000. Let me just check and see if I'm doing this. And it goes forever. If I reflect back to middle school, it comes down to being asked to do this. Take 9/10, add to it 9 over 100, which in decimals is 0.09. Add to it 0.009. Amir, that's supposed to go forever. But that's this plus this plus this in decimal. Guys, right now I have 0.9 where the 9 repeats. Back there was 0.3 where the 3 repeats. And you guys say, oh, that's 1/3. Adrian, what do you think 0.9 where the 9 repeats is equivalent to in mathematics?
9 over 9 or 1 in this case?
Tell me again.
9 over 9 or 1 in this case?
Just give me one answer.
9 over 9.
Which is?
1.
It's 1. Point 9 for the 9 continues. 0.9 for the 9 repeats. And you get to is 1. Guys, this could just drive you nuts. And you haven't seen the formulas for us yet. These two did not require formulas, they required a little bit of thinking. I thought I'd bring them in just to set you up on what a sequence is all about here, to sum up. Now, let me get into where we should be. Erase this. Miriam, do you have your handout near you, the one from Friday? I guess I passed out on Friday.
Yeah.
Okay. Would you tell me what on that handout did I have after that introduction to a sequence and then summations? Did I have some summation expressions to work with?
Yes.
Okay, I need, if you don't mind, we'll call this part 3. Would you please read for me, I'm trying to think when I did this handout, did I have something like this, the sigma?
Mm-hmm.
Did I start with 1 down here?
Yeah,
Did-
it was 1.
Okay, did I use an N or a K?
Okay.
Okay, K is equal to 1, and
At the top is 8.
where's how much?
8.
8. And what's inside?
2K.
2K.
And it says expand the sum.
And just expand it. Yeah, it's not too bad. Should be what, 8 terms, I guess? So if you had the time there, Amir, you could write out the 8 terms, and if you had the time, actually sum them up and say, Ramsey, I got the answer. That's all it means. That's all it means. Guys, let me quickly replace K by 1, I'll get a 2. Replace K by 2, I'll get a 4. Looks like the pattern here, 6, 8, 10, okay, 1, 2, 3, 4, 5, okay, that's 5, 6, 7, 8, and Miriam, I think you said to stop at 8, right? So if I replace K by 8, that's 16, so my last term should be 16. If I replace K by 8. Did I write those out correctly, guys? Now, if we had the time, I can sum these up. I don't need a formula right now. 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20, 10, 30, 42, 56, help me out, is it 72? I did it quickly. Is the grand sum 72? I just add them up. I hope I didn't make a mistake in the sum. Nope, it looks like 72 maybe is the correct answer. If I had those numbers up, I hope I had those numbers written out correctly. Do I? Is it 72?
I don't have a formula.
What's that? Yeah, this is 6, 12, 20, 30, 42, 56, and 56 and 6, is that 72? Did we have all the terms written out, guys? Barbaugh, is that correct? Okay, he says that's first 8 terms, Professor, 72. He said, Professor, please give me something like that. I can just write them out, add them up on the final, and get a grand sum. That's all the sigma says to do, add them up. Add them up, that's the summation. Adrian. Adrian, I'm calling on you quite much because you're a mentor to a lot of our students in class. You've been a big help this summer. We appreciate you. This one, I'd like to start with 1 and go through this, of this. I think Miriam told me on the handout was just 1 through 8. And I don't know, Miriam, did I try maybe 1 through something else on this, on the handout?
The next one's actually 3 to 6.
Okay, let me do this one first though. Now I'd like to do the same thing, except go through 100. That means I have 2 plus 4 plus 6 plus 8, so forth and so on. There's so many, I'm not going to list all of them, until I reach the end, and the end will be replacing K by 100 is 200. Now I need a sum for that. Good luck. There may be some clever students who maybe go through and group some things in there and get the answer. But now I need to add those up. Not as easily done as this one. I got 72 on this one. Just write them out and add them up. Not that obvious, not quite as easy on this one, but still can be done. Now, does anyone have an idea before I share with you what the textbook suggests you do on some of these heavy type problems? Does anyone have an idea what you could do on this? Before I show you anything else in class, does anyone have an idea how can you sum these up, get a grand total, and maybe throw a little creativity in there? Any ideas? Let me get it.
Do the same thing that we did for.
That's use the same thing Mr. Gauss did?
Yeah.
Right backwards? I mean, put 200 here. And I guess what, 198, I wouldn't make a mistake, was it? 198, I guess, next. And let's write another one in, 196, so forth and so on, until I reach 2. Miriam, good suggestion, be clever. Like Mr. Gauss did, write it backwards. I don't know how messy that's going to be, but let's see. This is 202. This is 202. This pair is 202. And what the rest of them will be, definitely this is 202. So you guys got a sum of 202 in the pairs, and I did that, what was it, 100 times? 202 times 100. That's what that number meant there. But that's when I did what? Yeah, I have to divide by 2 because I was adding twice. And that's what he did. Gauss did. And then this into this is 50. Still a big number. 50 times 202, whatever that big number is, and that's the grand sum. You got it. Finished. If I apply Gauss's method on this. Now, it comes down to this. We can do this all day. We can play around. I was thinking about, as I did my planning for today, I said, my goodness, I got to play around a little bit. Any instructor should show this. This should be shown. That infinity. And I came up to be 1/3. Just in terms of summation, when you first introduce summations, please just show that in your class. John.
Shouldn't 2 be pulled out and then multiplied by 2?
You could do many different things. You could take out 2. You could. I'm going to do that in a second. You could. But right now I'm using Mr. Gauss's little 7-year-old, his method. Miriam said do that. Looks like I got this big answer. I don't know what the big number is. 50 times, I don't know. Does anyone know what 50 times 202 is? Oh, Amir knows. Amir, tell me what it is.
10,100.
How much?
10,100.
10,100? Okay. Okay. Let him have that. Amir, put your name right there. 10,100. He says, no problem, Professor, just multiply it out. Now, Johnson's saying, Professor, suppose I don't have the inclination, I don't have the time, I like Gauss, I like what he did as a 7-year-old, line these up, it makes sense, and do this business to get the answer. Could you just give me a quicker way, Professor, and not make me think so much? Just give me a quicker way. That's where formulas will finally come in. And we have a little group of formulas that I'm going to be responsible for to get the answer. Now, before I jump into my formula, hang on. Miriam, please tell me what was next, and I'll come back to this. Ask, what was I asking on the handout next? Was it another summation?
Yeah.
Okay, hang on.
The sum of between k equals 3
Oh, 3?
and
6?
6. It's complicated. -1 in parentheses 2 k to the k plus 1
Oh, wow, okay.
times 2 to k.
Oh, that is cute.
Yes.
That is cute. Thank goodness Adrian is short. It doesn't go through infinity. That's fairly short, just from 3 to 6. So since it's short, guys, I'm going to start at the base, put a 3 in there. If I put a 3 into this strange expression, be careful. It's -1 raised to the 3 plus 1, 2 raised to the 3. And I'll come back to that. If I now try 4, it's a -1 raised to the 4 plus 1, 2 raised to the 4th. And then the 5th, okay, we got 3, 4, 5. The 5th one coming up would be a -1, 5 plus 1, 2 raised to the 5th. And Miriam, I think she said stop after I do the 6. So if I put a 6 in there, -1 raised to the 6 plus 1, 2 raised to the 6. Is that the way it looks expressed? And then just simplify, add them up, and you got the sum. This was not too bad, but watch the arithmetic here, guys. This says negative 1 raised to the 4th, that's going to be a 1. And times 2 cubed, that's an 8. No problem. This one says negative 1 raised to the 5th, we'll give you a negative. 2 to the 4th is 16, so we'll write like that, negative 16. Third term, negative 1 raised to the 6th, we'll give you positive 1. 2 to the 5th is 32. And I guess the last one's a negative 1 raised to the 7th, which will turn that into a negative. 2 to the 6th is 64. That's what it looks like expanded out from that summation. Add them up. That much is a negative 8. I guess that's 24. Guys, I see a negative 40. Now, I did that quickly. Is it negative 40? Can you add those up? So that's the sum of this to this of that strange expression she gave me. And notice I have not touched a formula yet. I'm sure. Miriam, was there something else before I jump into my formulas?
If I turn over the page,
If you flip the page over now, is that where I gave you the set of formulas?
there's 2 more problems in the section.
Tell me what the first problem is.
We did it already. It's the sum between k equals 1 and 100 of k.
Oh, beautiful, we did that.
And then the next one is the sum between k equals 1 and k equals 26 of 3k minus 7.
Hold on now. From k is equal to 1
Yeah,
up to 26.
yeah.
What's inside here?
3k minus 7 in parentheses.
Minus 7?
Mhm.
Okay. Let's try this one. And then I'm going to start my formulas, which will allow me, Jonathan, I know you're waiting for these, where I just apply a formula. Apply a formula. Not make much sense of it, don't have to write anything out, just use a formula. But right now, guys, if I write this out, start with 1 at the bottom there. Replace k by 1, and end up with a negative 4. I think the first term, what's my math? Replace k by 2, I see 6 subtract 7 is a negative 1. Put a 1, 2, put a 3 in there, I see 9 subtract 7, looks like a 2. Try one more term. 1, 2, 3, 4, put a 4 in there, 12 subtract 7 is 5. And she says, Professor, keep doing this until you finally reach 26. So at the end, put a 26 in there, 3 times 26, guys, I think is 78, subtract 7, I guess that's 71. And it looks like that. And they're asking you to go through and add all that. I see some negatives in here. Add them all up and get an answer. Miriam, do you think maybe I could apply Mr. Gauss's method on this one also? Add backwards? And go, I don't have a formula right now in front of me to use. Do you think I could apply Gauss's method on this one? Or maybe not. I'm going to pair these up. If not, I'll have to definitely go to formulas. Guys, put a 71 here. I'm trying to think backwards here. What would be right here prior to 71? I need that. 25, 75, subtract 7. Is it 68? Yeah. I think 68. Jeez. Okay. Oh boy. 26, 25, 24, 72, subtract 7. Help me out. 60. Oh. 75 subtract 7 is 68. What's the next term? How much?
65.
65. 65. And you go on and on and on till you reach the one down here, and I know that should be a negative 4. If you like to do it backwards like Gauss did. I don't know how much of a hassle that's going to be on this problem. These two would sum up, this pair would be what, guys, 67? Oh boy, I think. These two would be 67. This pair would be 67. Oh, Gauss is going to work. And of course, down here on the end, definitely 67. So I've got 67 26 times, but I've got to divide by 2 because I actually added twice. Now where that is, we do a little canceling there. 13 times 67, Amir, help me out. What's 13 times 67? that's 13 times 67.
871.
871? And that's your grand total. Now, Jonathan, I know what you and other classmates are thinking. You're thinking, Ramsey, if I add this or do like Gauss did, line these up twice and go through my business, it makes sense, of course. But it could be a hassle. Do you have a quicker way I can get the answer? And that quicker way is finding on that handout. There's a series of formulas, a group of formulas, okay, to apply real quick to get the answer. So guys, I'm gonna ask, Miriam, if you don't mind, I'm gonna ask you to help me out with formulas, and then we'll see how to apply these formulas. Now guys, when I say formulas, your final exam's coming up on Friday, as if you don't have enough to memorize already, there are some formulas here for summation. Now, can Miriam help me out? We call this part, that's part 3, part 4, finally. Let's see what this is all about. Miriam, describe the first one.
The first one is the sum, from k equals 1 to n.
To N.
Of CA subscript K.
Okay, I'm just call it C, okay? Got a C there. And was there anything else? Oh, C subscript K.
CA.
Oh, A.
K.
Okay. And what else? Oh, I got you.
So C.
This.
Yeah. Equals, you move the C in front and everything else is there.
All it comes down to, guys, looks a little strange. All it comes down to is, if you're asked to do a summation and there's a constant, right here, you're allowed to pull that constant out front, which might alleviate some worries there. But you're allowed to pull it out front, out of the way there, do your business, and then bring it back in later. Okay? Miriam, give me another one.
Okay, the second formula is, the sum between k equals 1 and n,
Okay.
parentheses, A subscript k plus B subscript k.
Beautiful. Hang on down. Let's see what this means for us, and we'll start applying these formulas. They're fairly basic, just written a little differently here. I think this one says I may separate them into
Yes.
two different sums. Just the notation looks a little strange here. Here. So guys, if I have a sum, I'm allowed to, by this formula, separate them. Which in time will help. Miriam, was there another one?
Yes.
Bring that to me.
If you just have a constant.
Okay,
at
beautiful.
the end,
And just a C here?
just the C,
Okay,
it'll equal C times n.
beautiful. Show you how to apply that. You have just a constant, no variables, just a constant inside. Before I jump in, have her list more for me. I'm gonna start applying these. Nima, on this one. Just for an example, right quick before I leave this one. If I start at 1 through, let's say 50, and all of a sudden inside there you see a constant of 4. You have sigma, for an example, you're going from 1 through 50, and all you see is, and she calls it a constant. She says, Professor, they said the formula should be this to get the answer. Why no little common sense on this one? This one says 4 plus 4 plus 4 plus 4 50 times. Which merely is a string of 4s 50 times summed up should be 200. What does your formula say here? Multiply these two together and get the answer quickly. N times C. So here 50 times 4, if that happens, I can apply that formula. Let's squeeze in letter D here. Miriam, you're helping me out. Tell me the next one.
Okay, this one's complicated.
Uh-oh. Okay.
The sum from k equals 1 to n
Okay.
of k
Okay.
equals n times n plus 1 all over 2.
Now, I'll tell you ahead of time before we start using this. this one's Mr. Gauss. We actually look at this and think about it, this is what Mr. Gauss was doing. Okay, that formula, I'll come back to that formula a little bit later on. And do I have just one more?
Yes.
I hope so. Okay, starts out with 1 again through n, and I guess it's k squared.
Mhm.
Okay, what's it say?
Says that is equal to n times n plus one times two n plus one all over six.
Now, your textbook gives a k cubed also, I'm not gonna hold you responsible for k cubed. So guys, if I see this, I have to know how to apply it. Arena, you're doing the math 8. Have you guys done, I know your professor's scaring very well. Has he talked about these summations yet, or are you guys there now? And do you actually have to use one of these formulas?
Yeah.
I got you. I thought so.
You said K squared is as far as we need.
That's all you need. Now we'll show you how to apply all this. Okay? There's just summation formulas. Now, I know my students by now, I saw some creativity on this last test. I saw some students doing some like problems on the test, and compared to the key, it was a little different. I thought, wow, what did they do? And I kept looking and looking and looking, all of a sudden I said, oh my God. Creative. Look out. I guarantee you some of these problems coming up will also work out for us in different ways. Okay. Now, that's my formulas. I'm sure there's some examples coming up here. Now, you're supposed to buy. One thing I noticed about my formulas, and I think one of my students in my 2 o'clock session was asking, all the formulas that Miriam gave me, they start with what? 1 at the base. 1, 1, 1, 1. Why don't they start at 2? So you see a problem on the final exam, it says sum from 2 to whatever. And you see that, and Caroline, you can't use the formula then. You use only these formulas if you can show me this has got to be a 1. It will start at 1. So you cannot use these formulas. Okay, that may happen on some people. Miriam? So that's,
For that though.
oh yeah, no, that's a different issue. Okay, tell me on the handout, what was my first example more than likely to find the sum of?
The sum between k equals 1 and 14
14.
of parentheses k squared minus 7k plus 6.
Plus 2. Now that's nice. That's what it's all about right there. That's nice. Now, when you see one of these on the exam, I will ask you to write out a few of the terms, not too many, just to make sure you understand what's going on here. But they're asking me to sum up. Guys, she's asked me to go from 1 through 14. Let me write a few of the terms out. If I replace k by 1, just help me out, replacing k by 1. I say 1 subtract 7, that's a negative 6. A negative 6 plus 2 gives me a negative 4 if there's no mistake. Now I'm going to go to 2, replace k by 2. Replace k by 2, that's 4 subtract 14, that's a negative 10, plus 2 is a negative 8 if I have no mistake. Guys, it goes on until you finally replace k by 14, which I will not do, but you could, to see what the last term is. So you could put a 14 in there and do the calculation, and that would tell you the value of the 14th term. She says, Professor, what they want you to do is sum them up. Just find the sum. They didn't ask you to write the terms out. I did a few of the terms. Just find the sum. I'm going to do it this way, guys. I'm going to separate it and rewrite this separated as summation from 1 through 14 of k squared. Subtract. Now, when I reach the second term, she gave me a formula for the second term. She says, Professor, if you have a constant inside there with your variable, you're allowed to move that constant out front. So I see a 7, pull the 7 out front, and that's gonna leave this. From 1 through 14 of K. And of course, last term would be from 1 through 14 of 2. There it is split up. Now, I think with Miriam's help, I have a formula for all 3 parts that I need here, I think. Now guys, the first one can be calculated by, look at this, the summation of K squared. She said, Professor, it's the strange formula. And that's what all it is, just a formula. I didn't show you where it came from. In fact, I don't think the textbook shows where it came from. So if I apply this formula for K squared, and I'm careful, guys, I'll have 14. That's n plus 1, 15. 2 times n plus 1 would be 29, all over 6. There's the first term with the help of this formula. Now, into my second term, I have a 7 out front, which I was allowed to pull out front. Now, summation of K from 1 through 14, she gave me a formula. Where is it? Oh, right here it is. Now I get to apply this formula for summation of K. N times n plus 1 over 2, that would be 14 times 15 all over 2. Done. The last one says just merely summation of a constant 14 times, and I think she says it's this one. Let's have a constant inside. And the fast way to find that is merely multiply these 2 together. C times n, they call it. In my case, just 14 times 2, 28. That's the easiest one. And then go through, simplify, calculate, get an answer, and find that grand sum. Guys, the first one's a little messy. Bear with me. I'm going to reduce it down a little bit. Let's reduce it down by 3. Let's call that a 2 and a 5. And then I could cancel 2 into 14 to get a 7. Still going to be messy. 35 times 29. Marina, do you have a calculator with you, or Mr. Park?
I have it.
Mr. Park, multiply 35 times 29. I just reduced it down.
1,015. 1,015.
1,050.
15.
15.
Uh-huh.
Hang on. So you're saying this?
Uh-huh.
Okay. You guys agree? I did it quickly. It says subtract from that 7 times my next one. Simplified. I can do a little canceling. That's 7. 2 into 14. 7 times 15, I think, is 105.
Mm-hmm.
And then plus 28.
Mm-hmm.
Just do the math now. Swing this out. That's 1,015. I have no mistake. I hope not. 7 times 105, guys. 7 times 105, I think, is 735. Plus 28. Now, Mr. Park,
Mm-hmm.
I could do this. Let's just stand here, but put all this together for me. See what it is. 1,015 subtract 735 plus 28.
308.
308.
Mm-hmm.
So guys, what she gave me up here, this is it. The grand sum, if there's no mistake, is 308. Bill, if you had the time, you could go through and just directly start adding these numbers up in red, all the way across, and see if sure enough, by the time you reach the 14th term, and add them all up, you're hoping to get a grand sum of 308. If you want to check it that way, at least we got formulas to work with. Guys, let's see, basic formulas, got them. I hope there's no mistake there. Okay, Miriam, what was next?
Last
Oh, the last one?
one.
Okay, hang on now. Letter F.
Mhm.
Okay.
And then this is from K equals 1
Oh, and that's where they always start with 1. Okay.
to 90.
90. Okay.
Of 3 minus 2.
3 3 minus 2n.
Mm-hmm. In parentheses.
Okay, I didn't use a K there?
You did not use the same.
Did I use K down here?
Yep.
Okay, that should be a K. So guys, correct that. I'll match up there. K, put a K in there. Okay. 1 through 90. Guys, replace K by 1 and we end up with 1, I think. Replace K by 2 and we end up with negative 1. K by 3, I think we end up with 3, subtract 6, negative 3, if that's correct. I did it quickly. Let's jump down to the 90th term. 3 subtract 180, negative 177. I think that's what it sort of looks like. And they're asking you now to go through and add them up. Be patient, add them up. And you know you're not going to be too patient here to add these strange numbers up, but they're asking you to do. Guys, we're going to separate this with the help of the formulas. Let's have summation from 1 through 90 of 3. Subtract the second term. The 2 can be placed out front of property. That allows that. 1 through 90 of K. And then apply the formulas. First formula, guys, 3, is that this formula? Where is it? Right here. You're still going to a constant n number of times. So it's merely 90 times 3, 270. And the next one, I think, is an application of this formula. N times n plus 1 over 2. I gotta keep in mind there was a 2 out front. So it's 90 times 91 all over 2. Make use of formulas. 270. 2 is canceled. 90 times 91. I'm standing here trying to do this, guys. Is it 8190? I did that quickly. Is it 8190? Okay. And then subtract those will be a negative answer. And guys, I don't know what that is. Mr. Parker, what's 270 subtract 8190?
270.
Subtract 8190. We'll get the correct answer here.
188 dot 1.
180?
188.1.
No, there's no point 1, 270.
Oh.
Subtract 8190.
Oh, okay. Negative 79.20.
Negative 7910?
20.
20. Whoa, whoa, whoa. So you're saying that?
Mm-hmm.
Thank you. Yes?
Yeah, so can I just see again what we did, like 270 minus 8, and then we together in the parentheses, do I see?
There's so many different ways to do these. Which one are you looking at?
I don't know, can I just see how we did that again?
Oh, this right here?
No, the one above.
Up here.
This, yeah, the thing on the right.
What did you want? Oh, this on the right.
Yeah, I just want to double check we got that.
Summation of K. You use this formula. N times n plus 1 over 2. 90 times 91 over 2.
Alright.
You gotta know your formulas. Just application of formulas. Okay. Miriam, was that the end of the handout? Oh, isn't that cute? Just a series of formulas to memorize, to know how to work and work with it and see if you can get the answer. John?
You're not gonna give us anything other than K equals 1?
Here we go. You're saying, what on
I
earth
don't
would
have to have
happen?
that.
Hang on though. Let's start with K is equal to 5. Let's say through 40 of 2K. Someone, cause John, I'm glad you asked. I see different ways to deal with it. Someone give me one way you can find where now we're starting with 5 and not 1 on this one. Someone give me an idea of how could you approach this and get the answer. 1 through, 40, hang on, she said, Professor, go back to the 1. Do that, find the grand sum. Jonathan? No, I guess what helps out.
And then.
Hang on. Let me get that done first. She says, Professor, rewrite this as, go back to your 1 through 40, 2K. But she says, you start at 5. That takes care of all of them. Is that true? They said just sum up from 5 on. So I'm leaving out how many terms? 4. Is that true? Now you're saying subtract from that then some of those first 4 terms. Tell me how would that be written with summation?
Let's do 1 to 5. No, is it 4?
Is it 4? Are you leaving out the first 4 terms or 5?
Oh, 4.
First 4 terms? And then inside here 2K? Jonathan?
Yes.
Good question. So you can go back to the 1 that they have in your textbook. Find the grand sum from 1 through 40. Then she says, no, Professor, you start at 5. So you're actually leaving out the first 4 terms. And so she says, subtract from that those first 4 terms. Guys, does that make sense? To do it that way or not? And then go through your calculations and you get the answer. So I'm glad you asked. Wow. Anything else on this? That's good. Now it's almost time for a break, and we should. Oh boy. Okay, here goes. Let's see how much time we got. We got 10 minutes. Summer class. Doing this, Oscar. If I were doing this through the regular semester, all these summations, this is what we've done here tonight, just tonight. Would have probably taken me a Monday and a Wednesday to do. Two classes. Just to get the formulas and how to use the formulas and so forth. But with this class, here's what we're going to end with, and I don't know how much, oh boy, I don't want to scare you. Nima, they're asking me now to prove some of these statements about summations that they really come from. Not necessarily derivation, but they give it to me and they say, prove it always works. Well, that means it infinity. Always works. I want to share this with you before we take a break.